Good evening. We'll continue from where we left yesterday. Y is equal to ax to the power of n plus 1 plus b over x to the power of n. Then a table is fixed. Asking is fixed. Asking bx to the power of n. Prove that n into n plus 1 into the problem. So in the say y2, or differentiate two times. First, let us arrange it properly. Ax to the power of n plus 1 can be differentiated because a is a constant. But here x to the power of n is in denominator. Bring it to numerator, then only we can differentiate. Otherwise, you need to use quotient rule. That is not required. Quotient rule should be used only when both numerator and denominator are functions of x. Here, numerator is not a function of x. Therefore, what you can do is you can just bring it to numerator. So, what is y1? A is a constant. This is n plus 1, x to the power of n plus 1 minus 1. Repeat, I am using this formula. dy by dx is equal to n x to the power of n minus 1. Here we have got n plus 1. Therefore, in place of n, I am writing n plus 1. I get this. Plus b into, here I got minus n. So, minus n x to the power of minus n minus 1. First derivative. Let us simplify this. A into n plus 1. This minus 1 plus 1 cancel. X to the power of n. Plus this becomes minus. This is a minus n bn minus bn x to the power of minus n minus 1. Let us differentiate for the second time. You differentiate for the second time. Oh, this is not y2, this is y1 only. We have simplified it. So now we shall go for y2. y2 is equal to a into n plus 1 is a constant. So you get a into n plus 1, keep it as it is. X to the power of n is n x to the power of n minus 1 minus bn is a constant. So this is minus n minus 1 x to the power of minus n minus 1 minus 1. N x to the power of n minus 1. But in place of n, you have got minus n minus 1. So we are writing that. Let us simplify this. A into n plus 1. Let us write in order. A into n into n plus 1. X to the power of n minus 1. So here I can take minus n common, it becomes b n into n plus 1. I repeat, by taking minus n common, I get minus of n plus 1. This minus will come here and this becomes plus x to the power of minus n minus 2. Because minus 1 minus 1 is minus 2. Now we need to find what is x square y2. X square y2 is equal to a into n plus 1 x to the power of n minus 1 plus 2. I am using the formula a to the power of m into a to the power of n is equal to a to the power of n plus n. So x to the power of n minus 1 into x to the power of 2 is n minus 1 plus 2 plus n into n plus 1 x to the power of minus 1 minus 2 plus 2. So here minus 2 and plus 2 will cancel. X square y2. You can take n into n plus 1 common. Because n into n plus 1 is here also and here also. So what do you get? Ax to the power of n plus 1. Why n plus 1? Minus 1 plus 2. Plus b x to the power of minus n, which is nothing but y. So that is equal to n into n plus 1. You have just followed the differentiation formulas. That's all. Nothing more. Here, I have used the formula y is equal to x to the power of n. The derivative is nx to the power of n minus 1. Same procedure we have followed. Let's go to the next problem. Y is equal to x square plus a square to the power of 6 to the power of 6. Prove that x square plus a square into y2 minus 10xy1 is equal to 12y. Y is equal to x square plus a square to the power of 6. You have to prove this. So same formula, but you need to use chain rule here. That's very important. You have to use chain rule. So I keep repeating. Finally, the rules and the tools are very, very important. It's whatever we are doing, just extension of what we are doing. So let us find y1. So this is, if you use chain rule, 6 into x square plus a square to the power of 5 into 2x. First, you should differentiate the power. 6x to the power of 5 in place of x over x square plus a square. Then you should enter inside x square is 2x, a square is 0. Now you can write this as 12x into x square plus a square to the power of 5. I repeat what we have done. We are using chain rule for differentiation. If you have got y is equal to u to the power of 6, dy by du is 6u to the power of 5. So in place of u, we have got this. Then I must differentiate u, that is x square plus a square. Difference in x square is 2x, a square is a constant. Now we have simplified this. The moment you simplify, you notice it's a product rule. X into something. That means you have got to use x to the rule. But I am differentiating this. you need chain rule again because there is a power. To differentiate this, first product rule, then when you differentiate x squared plus a squared to the power of 5, you need chain. These things you should understand. Once those ideas are clear, problems moves very systematically. Now, let's go for y2. Because 12 is a constant, I'll keep it outside. Now I am concentrating on this. So I keep x square plus a square to the power of 5 as it is and differentiate x, I get 1. Recall what we are doing? We are using product rule. dy by dx is equal to b into du by dx plus u into dv by dx. I am repeating it number of times because there must be repetition but not omission. So here I am calling x as u, this as v. So I keep v as it is. V is x squared plus a squared to the power of 5. And differentiate x, I get 1. Now I should keep u as it is. So u is x. I should differentiate this chain rule. 5 into x squared plus a squared to the power of 4 into 2x. Same procedure, you had 6 here, we got 5. We got 5 here, we got 4. Here also we got 2x because after differentiating the power, we have to enter inside and differentiate x square, that is 2x. Same procedure, a square is a constant. This also we shall simplify. You have got 12 outside. So this is 12 x square plus a square to the power of 5. Plus, how much you get here? 5 to the 10. 120 you get. X square into x square plus a square to the power of 12 into 1 is 12. 5 into 2 is 10. X into x square. When you multiply that by 12, you get 120. Now, we have to arrive at that. This is y2. What is asked the problem? X square plus a square to the power of 5. So multiply this by that, you get x square plus a square to the power of 6. 5 plus 1 is 6. Number 5, I'm sorry. This you have to write here. X square plus y square. X square plus a square into y2, not 5. Into y2. So I am multiplying y2 by x square plus a square. So 5 plus 1 is 6. I am multiplying this also. I get 120 x square plus a square to the power of 5. I am multiplying y2 this expression by x square plus a square. You got 5 here, 5 plus 1 is 6. You got 4 here, 4 plus 1 is 5. What is the next term? Minus 10xy1. So take that term. You have to multiply y1, this is y1, this is y1, simplified version. By how much? Minus 10. So it becomes minus 120 x square plus 8 square to the power of 5. I am multiplying y1 by minus 10. Let us close this. So here what will happen is these two will cancel. You get x square plus a square y2 minus 10xy1 is equal to, what is this? This is a y, that is nothing but y, 12y. So we have differentiated twice. We have substituted this, we are getting the equation. Let's go to the next problem. I'm working more problems here so that when you start solving question papers, some of the problems I can skip because I would have covered it here. Just don't watch, prepare the notes also. Then when we start the question papers, it will be easy for you to refer because you can't go back to the video. So I've made this point very clear in the beginning itself. We really want to get the benefit from this copy, whatever is done. Just imagine you are in a class and start working. Otherwise, when we start solving question papers, some of the questions I will say we have already done it. So that becomes a problem for you because you can't refer to the video all the time. Okay. Next, if y is equal to e to the power of ax into sin bx, e to the power of ax into sin bx, prove that y2 minus 2x y1 plus a square plus b square into y equal 0. Now, what is y1? It's a product. So you got to use product rule. Let us keep sin bx as it is. Differentiate e to the power of ax. It is a standard one. A e to the power of ax. Plus keep e to the power of ax as it is. Differentiate sin bx. It is b cos. And repeat what I have done. I know. I realize that it's a product. I need to use product rule. So I have to keep one of them. I have kept sin bx as it is. Differentiated e power ax, that is a e power ax. Now I have to keep e power ax as it is. Differentiation sin bx is b cos bx. Now before we go further, let us simplify so that we shall write in the proper order. y1 is equal to a e to the power of ax. I'm not doing anything, I'm just writing in proper order. Plus b e to the power of ax into cos bx. So I have just written in the proper order. I have taken a here. Now we should differentiate for the second time. Here a is a constant. Again e to the power of x sin bx is there. Product rule. Keep sin bx as it is. Differentiate e power x. E power x. Plus keep e power x as it is. Differentiate sin bx. You get b cos bx. Plus you keep b outside because b is a constant. Again product rule. Keep cos bx as it is. Differentiate this e power ax. Now keep a power ax as it is. Now you are differentiating cos bx. You get minus b sin bx. I'm just writing it. I'm just taking this minus sign here so that I can avoid one step. Otherwise, if I write here again, I have to simplify. I just spend 1 more minute extra. So you get minus b sin bx. I have done minus sign here. This we are going to simplify. y2 is equal to multiply by a square e power ax sin bx plus a into b plus ab e power ax cos bx plus a into b ab e power ax cos bx minus b square there is no a here because you have kept e power x as it is. You have differentiated sin bx, you get only b. So minus b square e power x sin bx. See, one good thing in mathematics is, supposing you are getting any mistake, you can find out. Supposing if a is there, it looks very absurd. So what's the mistake we have done? Here I have kept b cos bx, differentiate a power ex. I got differentiating e power ax. Here I should keep e power ax as it is. Differentiate sin bx, I'm sorry, cos bx. Therefore, there is no a here. Now, can simplify this? A square e power ax sin bx. And you notice that these two terms are same. Plus 2ab e power x cos bx minus b square e power x. Now we have to work that problem. Which one? What is the rule? So once you do the differentiation properly, what is it? Put y2 y2 minus 2x y1, yeah, y2 minus. So we have to find out y2. y2 is written as it is. A square e power ax sin bx plus 2ab e power x cos bx minus b square e power x sin bx. Now they want 2x y1. 2x y1 means you should multiply y1. Oh, I removed y1. There was y1. We need y1. I have removed it. What was y1? y1 was a e power ax let me work that problem because I removed y1. It becomes a problem for me now. I require y1. I'll work again because I should not have removed it. I'll just work y1 again. If y2 we have copied, I need y1. I'll work again. What was the problem given? Y is equal to e power ax sin bx. What was y1? y1 is, you keep sin bx as it is, you get a e power ax sin bx and keep this as it is plus b e power ax cos bx. Because I keep e power ax as it is, the sin bx as it is, differentiate this, I get a e power ax. Now keep e power ax as it is, sin bx is b cos bx. So you have to multiply this by 2a. So you will get minus 2a square e power x sin bx minus so I am multiplying by 2x y1. So y1 is second term. So you will get I think there's some mistake in the problem. Let me check the problem. It is not 2a y1. Please make a correction. The actual problem is prove that y2 minus 2a y1 plus a square plus b square into y. So it's not 2x, it is 2a. So 2a into 8 minus 2a square minus 2ab e power x cos bx. Please make a correction, it is 2a. Now I have to multiply a square plus b square into y. So this is y. I have to multiply by a square. I get a square e power ax sin bx. So this is one advantage. Supposing there is some mistake in copying or some mistake, you will get some terms which are not matching with this, because the terms that you get are all very symmetric. The moment we notice something wrong, some other term is coming. So it's very clear whether the problem is not copied properly, or we have, just as we had gone wrong in that writing 1A outside for the 1A for the last one. So not required. So you can always cross check. It is always possible. But you have to concentrate on what you are working. Plus b square e power x sin x. So when you combine these two, or when you add all the left hand side and right hand side, the left hand side is y2 minus 2a y1 plus a square plus b square into y is equal to, these three will cancel, these two will cancel, and this will cancel. That is equal. Go through the problem once again. There was, I just rectify. The mistake was I should have written 2a here. I had written as 2x, and then differentiation we are using product rule. When there is a product, for the first differentiation you will get two terms. For the second differentiation you are going to get four terms, because again each term is a product rule. Let's go to the next problem. If y is equal to sin inverse x, if y is equal to sin inverse x, prove that 1 minus x square y2 minus xy1 is equal to. So these are all very simple problems if you know the method. If method is not known, it becomes very complicated. I'll just show you how. First find out y1. It is 1 over root of 1 minus x square. Now we have to go for second differentiation. Normally what we do is, we write this 1 minus x square to the power of minus half and use chain rule. That is very complicated. That's why I am teaching you what is the method. You multiply root of 1 minus x square into y1, that is equal to 1. Many students ask me a question, how do we know that we are going to multiply? And when you multiply, the problems become easy. The only answer for that is I am teaching you. This is the method. How do I know? My teacher taught me. How does your teacher know? So that's why some of the methods in mathematics are circulated from one level to another level. Supposing if you don't use this method, cross multiplication, and use a normal method, 1 minus x square to the power of minus half, things becomes very complicated. See how easily this works out. Now 1 minus x square, of course root is for the entire thing. 1 minus x square into y1 is a product. So we need to use product rule. So I keep 1 minus x square as it is and differentiate y1, I get y2. Now I have to keep y1 as it is and differentiate this. The differentiation of root is 1 over 2 root 1 minus x square into minus 2x. And y1 also I should keep it as it is. This is 0. I repeat. I keep 1 minus root of 1 minus x square as a product rule. I keep this as it is, differentiate y1, I get a y2. Now I keep y1 as it is, I have written it here so that I can avoid one more term. One more step rather. So differentiation of root is 1 over 2 root. Enter inside, 1 is 0, x square is 2x. There is minus x square minus 2x. You can cancel this and this. So multiplying by root of 1 minus x square. What do we get? So when we multiply, this root will cancel, you get 1 minus x square. Right. When you multiply this and this will cancel, you get minus xy1. That is equal. So when I multiply this root into root will cancel. When I multiply this denominator and this will cancel, you get xy. So easy. You know the procedure. We'll work one more problem. If y is equal to tan inverse x, prove that 1 plus x square by 2, 1 plus x square into by 2 plus 2xy1. These are all problems which have been asked in the examination number of times. Very simple, it carries 3 marks. You get the answer in just 3 steps only. What is the first step? You are differentiating. Left hand side is y1. This is 1 over 1 plus x square. What is the next step? Cross multiply. You get 1 plus x square into y1 is equal to 1. Now product rule. 1 plus x square into y2. I keep 1 plus x square as it is. Differentiate y1 again y2. Now I have to keep y1 as it is. Differentiate 1 plus x square. I get 2x because 1 is 0. 2x y1 is equal to 0. You get this solution directly. So this problem carries 3 marks. Supposing if you don't know this method of cross multiplication, if you start writing 1 plus x square to the power of minus 1, use chain rule, the problem becomes complicated. So that is the reason that you need a mathematics teacher to learn mathematics. Because all problems doesn't go on the same lines. Let's go to the next problem. This may not be asked, but still I just want to work to give you a little more knowledge about this. They may not ask, but I am working so that by working a problem which is little more standard than what is asked in the examination, you might have better ideas. There are many problems, I just working for only one of them. Some places I am just working 1 or 2 extra problems which is little above your standard, but not too much, you can certainly understand. Now, differentiation of this y1, y is y1. This is a product rule. Sorry, chain rule, because the power is there. First, we should differentiate that. First, power 2 sin inverse x, then differentiate sin inverse x, you get 1 over 1 minus x square. Problem on chain rule. First, I am differentiating power 2 sin inverse x, then I have to enter inside differentiate. You can guess what is the next step? Cross multiply. Y1 is equal to 2 sin inverse x. Now again, about to integrate the differentiate using product rule. Keep root of 1 minus x square as it is. Y1 differentiation y2. Now, you have to differentiate this root is 1 over 2 root 1 minus x square into 1 is 0, x is minus 2x. Y1 we have kept as it is. That is equal to 2 is a constant. Sin inverse x is 1 over root of 1. We are using product rule here. I keep y1, this as it is, y1 is y2. I keep y1 as it is, differentiate this, I get 1 over 2 root. Then I have to enter inside, 1 is 0, x square, 2x, but there is minus x square. So this 2 and 2 you can cancel. What is the next step? Multiplying by root of 1 minus x square. What do you get? This root will go. Here this term get cancelled, but there is minus sign. And here also it will cancel. That's the required answer. However, one more problem of this type, so that you get a better idea about these types of problems. Instead of sin inverse x, I will take cos tan inverse x. Again, I am repeating, this may not be asked in the examination. I am working it only for the sake of creating little more interest or giving you a little more knowledge, so that when you work a standard problem, the problem that you get in the examination becomes very simple. The problem that I am taking is, if y is equal to tan inverse x whole square, if y is equal to tan inverse x whole square, to that 1 plus x square whole square, 1 plus x square whole square into y2 plus 2x into 1 plus x square plus 2x into 1 plus x square into y1 equals to same procedure. Differentiation y is y1. First you differentiate the power. Then we had sin inverse x whole square. We have got tan inverse x divided by 1 plus x. Then we got 1 over root of 1 minus x square, because the problem was sin inverse x. Here differentiating tan inverse x. Second step is same. You have to just cross multiply. This step is same as the previous problem. The only change, instead of root of 1 minus x square, you have 1 plus x. So what is the procedure? Product rule. Keep 1 plus x square as it is. Differentiate y1. You get y2. Keep y1 as it is. Differentiate 1, that is 0. You get 2x y1. Keep y1 as it is. Differentiation of 1 is 0. X square is 2x. Now 2 is a constant. Tan inverse x is 1 plus x. What is the next step? Multiplying by 1 plus x. What do you get? This becomes 1 plus x square whole square y2 plus 2x into 1 plus x square into y1. That is equal to. Just go one more step ahead to give you a clear idea of how these types of problems works out. And if you solve 4 or 5 problems, remaining problems you can automatically solve it, because the procedure is almost the same. So I'm just working one more problem which is also not in the syllabus. Still I am working for the sake of creating more interest in different. And by working in these problems which are little above standard, your examination problems becomes easy for you. If y is equal to e to the power of m sin inverse x. E to the power of m sin inverse x. Prove that 1 minus x square by 2 minus x by 1 minus m square y is equal to. This is not in your NCERT textbook, but still I am working. Y1 is e to the power of anything is e to the power of same thing. E to the power of x is e to the power of x only. So you can take this as x. So it is e to the power of m sin inverse x as it is. Now we are using chain rule. Now I should differentiate m sin inverse x. M is a constant. Sin inverse x is root of 1 minus x. E to the power of everything is e to the power of same thing. I will differentiate m sin inverse x. M is a constant. Sin inverse x is 1 over root of 1 minus x square. Again, guess the next step. Cross multiply 1 minus x square into y1 is equal to m into e to the power of m sin inverse x. Now, again, product rule, keep 1 minus x square, root of 1 minus x square as it is. Differentiation of y1 is y2. Now I keep y1 as it is. I differentiate this 1 over 2 root 1 minus x square into minus 2x multiplied by y1. This is equal to m is a constant. Keep it as it is. This e to the power of anything is e to the power of same thing. Then I must differentiate this. I get m over root of 1 minus x. If you observe, you can see the same term they have done here. So here keep m as it is. Now same as what we have done there. You see here, this and this part is same. That means we are differentiating this. E power anything is e power same thing. Then m is a constant. Sin inverse x is root of 1. You can cancel this 2 and 2. What is the next step? Multiplying by root of 1 minus x square. So this will go, root will go 1 minus x square y2 minus xy1 minus xy1 is equal to m and m square e to the power of m sin inverse x. That is nothing but m square. We will go for the other types of problems which are asked in the examination. Today I work some problems which are little more standard than what is prescribed in NCERT, only for the sake of interest. Now I just take up the problems which are usually asked in the examination. Take the next problem. If y is equal to, these are all examination problems. If y is equal to 3 cos log x, 3 cos log x plus 4 sin log x. Prove that this is normally the 4 marks question. There will be one question on successive differentiation every year. x square y2. Very simple. And those students who are not that good in calculus, but still by at least by doing one differentiation, you get 1 mark. Every marks add up to give you the passing marks. So wherever you can grab the marks, you can concentrate. Concentrate on those areas where at least you can get 1 mark. Not for all, for those who are scared of the examination, those who have got a feeling I may not pass. So these are the areas where you can suddenly get 1 mark. May not be able to, but most important thing is whatever you write clearly. And always leave sufficient space in between so that whatever you write becomes or observe, whatever becomes right, you write will be clearly, neatly read by the examiner. You must always know that if a paper is corrected by a person who is not known to you. Therefore, you have to write legibly, neatly. You may not have a good handwriting, at least you can write neatly. It's always possible. So let me work this problem. Y1 is equal to 3 is a constant. So you should know that this is a chain rule problem. So first you differentiate cos, then log. So what is the difference of cos? Minus sign, whatever is there you write. And differentiate cos, I get minus sign. Why we should put a bracket? Because if you don't put a bracket, you may consider that a different term. But this has to be multiplied by 3. So whenever minus sign is there, always use bracket to avoid confusion later. Divided by x, which is of x, differentiation of log x. Keep 3 as it is. Differentiate cos, you get minus sign. Differentiate log x. Same procedure. Keep 4 as it is. Differentiate sign first. You get cos log x and differentiate x. And guess the next term, multiply it through by x or shift x to the left hand side. You get minus 3 sin log x plus 4 cos log x. Repeat once again. You should realize the problem of chain rule. So 3 is a constant. Why should I put a bracket? If you don't put a bracket, this minus sign will create a confusion. You may read this as 2 different terms. It is not so. Therefore, put a bracket. Cos is minus sign. Here the bracket was not required. There is no minus sign. But for uniformity, I will put bracket. So difference of cos is minus sign. Log x is as it is. Then differentiate log x. Same procedure here. Afterwards, we have multiplied by x. Now, we should differentiate. Use which rule is the same thing, product rule. Keep x as it is, differentiate y. Y1 you get y2. Keep y1 as it is, differentiate x you get 1. Minus 3 is a constant, keep it outside. Differentiate sign first, you get cos log x. Different sign is cos and log x is x. Same procedure. Keep 4 outside. Cos is minus sign. Log x divided by x. Now again multiply it by x. X square y2. X square y2 plus xy1 is equal to minus 3 cos log x plus 4 sin log x. I've taken minus sign outside. You notice the minus sign, take it outside. This is nothing but y. Because that's a given problem. So bring y to this side. X square y2 plus xy1 plus y. Here there is a minus sign here and a minus sign here. Taken minus sign common. This is why we get this solution. Let's go to the next problem. If y is equal to 500, this is an examination problem only, e to the power of 7x plus 600 e to the power of minus 7x. Prove that d square y by dx square (49y). By working in this problem here, I am saving time and I am doing the examination problem. The same problem we have repeated. So 500 is a constant. There is no product rule is not required. But they are separated by, here also 600 is a constant. But two terms are separated by a plus sign. So you need to use addition rule. So what is y1? 500 you keep as it is. It is 7 e to the power of 7x plus 600 as a constant. This minus 7 e to the power of minus 7x. So what we can do is, both has got 7, I can take 7 common, and both has got 100, so I will take 700 common. E to the power of 7x, I'm sorry, 5 e to the power of 7x minus 6 e to the power of minus 7x. I will take 1 minute extra here to explain what I have done. From these two I have taken 100 common, therefore I get 5. In the real thing, 500 into 7 is 3500, same thing you get here. 600 into 7 is 4200. So I have taken 100 common from these two, and I have taken 7 is there in both. Now I will go for second differentiation. So here let us not use y1 because they are given in the form dy by dx. So let us call it dy by dx. Let's go to the second derivative. D square by dx. This is dy by dx only. This is dy by dx on simplification. Now we have to go for d square by dx. 700 is common. 5 is common. E to the power of 7x is 7 e to the power of 7x. Therefore 35 e to the power of 7x. And 6 is common because you have to keep it as it is. Ku, keep 6 as it is. Differentiate e power 7x, you get minus 7. Therefore it is 42 e power minus 7x. Now, you can take 7 common between these two. So 4900. This is 5 e to the power of 7x plus 6 e to the power of minus 7x. But they want you to prove it is 49y. So what we can do is send 100 inside. This becomes 500 e power 7x plus 600 e power minus 7x. This is nothing but 49. So always look at the answer. We have got 4900 here, but they want 49y. So you have to send 100 inside to get back the problem. Let's go to the next problem. if y is equal to almost identical problem, y is equal to 3 e to the power of 2x plus 2 e to the power of 3x. See the symmetry of the problem. This is 3 e to the power of 2x, that is 2 e to the power of 3x. Prove that y2 minus 5y1 plus 6y equals 0. Now, y1 is e to the power of 2x is 2 e to the power of 2x. Therefore, this becomes 6 e to the power of 2x. 2 is a constant, e to the power of 3x is 3 e to the power of x. This also becomes 6 e to the power of 3x. So we will take, or let us keep it as no problem. We'll go for y2. What is y2? This becomes 12 e to the power of 3x. And this becomes 18 e to the power of 3x. So y2 is here minus 5y1, 5 into this 30, this e to the power of 2x. This is. So this is minus 60 e to the power of 2x plus 90 e to the power of 3x plus 6y is equal to, this is 6 into 3, 18 e to the power of 2x, and this is 12. There is some problem. Well, 6 e to the power of 3x, 2 e to the power of 3x is 6 e to the power of 3x, 6 into 2 is 12, 6 into 18, minus 5y1, multiplied by 5, divided by 30. It is 5y1. So 5y minus 5y1 is, y1 is here, multiply by, this is equal to minus 30 e to the power of 2x minus 30 e to the power of 3x. You have to multiply y1, I multiply y2 actually. So this y2 is here. I am not writing y2 again, I am keeping this y2 as it is. Now 6y. So I have to multiply this by 6. I get 18 e to the power of 2x and I get 12 e to the power of 3x. I repeat, I have kept y2 as it is. 5y1 means I need to multiply y1 by 5, that to minus 5. So minus 30 and this also minus 30. 6y means I have to multiply y by 6. So when I add these two, left hand side and right hand side, y2 minus 5y1 plus 6. This will cancel, this will cancel. These are all the problems which are asked in the examination of second derivative, and one question from second derivative always. And there are hardly about 12 or 15 problems, we keep repeating. I think Sai University schools which I worked, they have repeated in 2 or 3 years. Anyway, when we take up the paper, we will just know how many times some of the problems are repeated. So I want to start the answering question paper tomorrow. But I am writing some of the formulas which are required for later purpose. I have about 20-30 minutes time now. I thought I will give you the list of formulas which are required for you to work the problems. And this list, if you keep it with you, it will be helpful for us. And I'll not be writing the formulas again. Once we start working with examination papers, I will ask you the list of formulas again. Please refer to it. So it's better if you list these formulas. First formula, sin of A plus or minus B. It is sin A cos B. It's not that you are not familiar, but I am just repeating cos A sin B. Cos of A plus or minus B. Cos A cos B minus or plus sin A sin B. Tan of A plus or minus B. Tan A plus or minus tan B over 1 minus or plus tan A tan B. If all the formulas that I am writing today, they are in your fingertips, working problems in examination is going to be very easy because you require these formulas. Next, multiple angle. Sin 2A is 2 sin A cos A. By writing these formulas, I will be saving a lot of time when I do the examination. Otherwise, I have got to write again. So, please remember this formula 2 tan A over 1 plus tan square. Cos 2A cos square A. I am not deriving any one of the formulas, I am just listing them. Sin square A 2 cos square A minus 1 minus 2 sin square A 1 minus tan square A over 1 plus tan square. Tan 2A 2 tan A over 1 minus tan square A. Of course, if you know sin and cos, you can divide it also, you can get this. Now, half angle formula sin A by 2 is equal to 2 sin A by 2 cos A by 2 2 tan A by 2 1 plus tan square. I am just writing only for sin A by 2. You know that what we have done is, I have divided this 2A by A, it becomes A. All this becomes A by 2. Similarly, we can derive the formula for the cos half angle formula. Sorry, this is not sin A by 2, sin A is equal. Sin A is equal to 2 sin A by 2 because we are dividing sin 2A by A. Similarly, we can find cos A tan A. One more formula we need is, most often we require this 1 minus cos A is 2 sin square A by 2 1 plus cos A is 2 cos square A. All these formulas must be remembered. If you can remember all the formulas, then you can sure of getting 100 because we use marks in examination because of not remembering the formula. Sin 3A 3 sin A minus 4 sin cube A. cos 3a 4 cos cube a minus 3 cos e tan 3a 3 tan a minus tan cube a over 1 minus 3 tan square a. Tan of 45 minus a 1 minus tan a or tan plus 45 plus or minus a 1 plus or minus tan a or 1 minus or plus tan a. Well, we can write the next formulas. These are the formulas which are required. I just want to, because these things are not going to write, these are very simple. Sin square a plus cos square a is 1 and all that. They're all basic and not listing that. But I'll just take some problems of differentiation where by remembering these formulas, how easily you can work those problems. They are pertaining to implicit differentiation. I told you in last class when I was doing implicit, I just worked 1 or 2 problems. Today I would like to concentrate little more problems using these formulas. So let's go for that. The first one. Find dy by dx. Y is equal to cos inverse of 1 minus 2x square. See, normally we think of the following substitutions: sin theta, cos theta, tan theta. If 1 minus x square is there, go for sin theta. If x square minus 1 is there, go for secant theta. Those things you learn by practice. If 1 plus x square is there, so I can just give you a hint. But here what happens is 1 minus x square is not there. 1 minus 2x square is there. So I have to go by trial and error. If I put cos theta, 1 minus 2 cos square theta, there is no problem. Formula. Whereas if I put sin theta, I know the formula cos 2a is equal to 1 minus 2 sin square a. Immediately I should remember this formula. So put x is equal to sin theta. Then what is y? Cos inverse of 1 minus 2 sin square theta. That is cos inverse of cos 2 theta. That is 2 theta. But what is theta? Theta is sin inverse x. So what is our answer? dy by dx equal to 2 root of 1 minus x square. Because 2 is a constant, sin inverse x is root of 1 minus x square. Let me repeat what I told for the students who cannot remember or finding difficult to remember the formula. In case this problem is given, then at least get 1 mark. How to get 1 mark? You remember, if y is cos inverse x, is only for those who leave the problem instead of leaving it. You just do write one step. Thereby you can get at least 1 mark. What is dy by dx? Minus 1 over root of 1 minus x square. So what you do when you do, remember the formula. When you are not able to recognize the formula you need to use. But if you are putting chain rule, you must be putting chain rule because you have done so many problems. Can use chain rule. You may not arrive at the solution. See, if they are given, prove that dy by dx is equal to 2 over root of 1 minus x square. Then you need to simplify and you get the complete solution. Then only you get the marks. Suppose if they are given find dy by dx. then you can use same rule and get complete marks also. Minus 1 over root of 1 minus 2x square whole square. 1 is 0 minus 4x. Leave it like this. If it is given as find dy by dx, if it is given as prove that, you will not get the complete marks. Even if I prove that also, the last classes I told you, if they give the answer, it's an indication. If 1 minus x square is there, it is either sine or cos. So I put cos, I won't get, but let's put sine. Leave that constant as it is, 1 over root of 1 minus x square. In fact, it is sine only, not cos, because cos differentiation is minus sine you get. When there is no minus sign, it must be sine. Because on sine inverse x on differentiation gives 1 over root of 1 minus x square. So you are getting a hint. So you can put x equals sine theta. I'll take another 1 or 2 more problems of this type, where you need to remember the formulas. So that once I start the question papers, I can save a lot of time and saying that the formulas have been already listed. Cos inverse of 1 minus x square over 1 plus x. See, for 1 minus x square, if I put sin theta, it simplifies. 1 minus x square, that is cos theta. But 1 plus cos square, there is no formula. But 1 plus tan square theta is secant square theta. But what is 1 minus tan square theta? So you need to remember the formula. Cos 2a is 1 minus tan square a over 1 plus tan square. So if you remember the formula, you can put x is equal to tan theta. Then y is equal to cos inverse of 1 minus tan square theta over 1 plus tan square theta. You know this is nothing but cos 2 theta. Y is equal to cos inverse of cos 2 theta. I am using inverse trigonometry formula. This is 2 theta. But what is theta? Theta is tan inverse x. Because we have taken x as tan theta. So what is dy by dx? 2 over 1 plus x. So if they are given, prove that dy by dx equals 2 over 1 plus x square. Then also you can work it out because 1 over, leave the constant 2. 1 over 1 plus x square is the derivative of tan inverse x. So put x equals tan theta. So normally, if proof that is given, it will in a way it's going to help you. Substitution that you can choose. Again, supposing it is not given as proof that simply given dy by dx, then differentiate and leave it. And you don't know the formula, then also what you can do is dy by dx, use same rule. Minus 1 over root of 1 minus x square or 1 plus x square whole square multiplied by, this is quotient rule, 1 plus x square into minus 2x minus 1 minus x square into plus 2x divided by 1 plus x square whole square. If you leave it like this also you get the marks, but only for the sake of interest, I want to simplify this and show how we get this. It's not the actual method, but only for the sake of interest, if you work like this also, you get the marks. But you need to be good in simplification. Let me explain that. Sorry, I take LCM. So because whole square is there, so it becomes 1 plus x square. LCM is 1 over 1 plus x whole square. That will come to the numerator. This is root of 1 plus x square whole square minus 1 minus x square whole square. I think you can understand this. I'm just writing the steps here. It is 1 minus x whole square over 1 plus x whole square. I take the LCM 1 plus x whole square, 1 plus x whole square, 1 plus x square, 1 plus x square whole square is the LCM. So this is 1 plus x square whole square minus 1 minus x square whole square. When you take out the root, you get 1 plus x square, that is separated. Now, you need to simply other one out. The denominator is 1 plus x square whole square. These two you can cancel. No, you cannot cancel totally. Because you have got 1 plus x square here. Here whole square is there. So you can cancel 1 plus x square, 1 remains here. Because whole square is here. Now you can take 2x as a common factor. 2x is here also here, but there is a minus sign. Minus 1 minus x square. This is minus 1 plus x square. So plus x square and minus x square cancels. You get minus 4x over root of 1 plus x to plus 2x square plus x to the power of 4 minus 1 minus 2x square minus x to the power of 4. A plus b whole square, a minus b whole square. This becomes plus because there is a minus sign. 1 is negative because you get plus sign here. You get minus 2x square, that becomes positive. Now what will cancel? X to the power of 4 will cancel. 1 also cancels. Multiplied by 1 over x square is there. Now, what do you get? There is a minus sign. I don't know why I have a minus sign. There is no minus sign. Yeah, there is a minus sign. And here it is minus 4x is there. That minus 4x I have taken here. It becomes minus into minus plus 4x. Repeat. This minus sign is because of cos inverse differentiation. You get minus 1 minus 2 into x minus 4x, it becomes plus 4x. And 1 over 1 plus x remains as it is. So this is 4x over 2x square plus 2x square is 4x square. Root of 4x square is 2x into 1 plus x square. X and x cancel. We get the solution. But how complicated this is. So if you use a trigonometry formula, you get the solution easily. But I just suggest the students practice this also. Thereby, you are improving your simplification, but not now. These things I tell the student at the beginning of the year. Now we can't afford to do that because we are very close to the examination. So best thing is, if they are given, prove that you get a hint from the answer itself, put x equals tan theta and work it out. Or else you can just differentiate using chain rule and leave it. At least you get 1 mark. Sometimes the problem carries 3 marks. Some examiners might give 2 marks also because they use chain rule also and product rule. It's a quotient rule. One more problem of the where the trigonometry is required. Sine inverse of 2x into root of 1 minus x. Here also, if it is given as product, you get a clue. If it is not given as product, simply given, you have to just think of trigonometry formula. If I use x is equal to sin theta, what do I get? 1 minus x square. So put x equals sin theta. Trial and error. Substitute what you get. Sin inverse of 2 sin theta into cos theta. Why do I get cos theta? Because root of 1 minus x square is root of 1 minus sin square theta is cos theta. Actually cos square theta root will go. But what is 2 sin theta cos theta? It is sin 2 theta. Sin inverse of sin 2 theta. That is equal to 2 theta. What is theta? Sin inverse x. So what is dy by dx? 2 over root of 1 minus x. So if they are given through that, you are getting a clue from the answer. So they have given positive answer. It must be sin inverse x derivative. Then put x into sin theta. Or else, if you cannot remember the formula, you can go by chain rule, but it is not that easy. Differentiate sin inverse, then you have to differentiate 2x into that. That's the product rule. Again, root of 1 minus x square is the chain rule. The problem is going to be tougher than the other one. Anyway, instead of leaving the problem, you can just write 1 or 2 steps and y is equal to secant inverse of 1 over 2x square minus 1. See, 1 minus 2x square is there. You can use sin theta because 1 minus 2 sin square theta is cos square theta. Sorry, 1 minus 2 sin square theta is cos 2 theta. Whenever 2x square minus 1 is there, you have to put x equals cos theta because that formula also you should remember. 2 cos square theta minus 1 is cos 2 theta. 1 minus 2 sin square theta is also cos 2 theta. We got one problem in 1 minus 2x square, we use sin theta. This is 2x square minus 1. So put x is equal to cos theta. So what do you get? Y is equal to secant inverse of 1 over 2 cos square theta minus 1. That is secant inverse of 1 over cos 2 theta. That is secant inverse of secant 2 theta. That is 2 theta using inverse trigonometric function. But what is theta? Theta is cos inverse x. So what is dy by dx? Minus 2 over theta. You should realize that you have to put x is equal to cos theta. I'll just work one more problem and leave. Y is equal to cos inverse of 2x over 1 plus x. This is slightly somebody has asked a questions square root of cos square x when taken should be absolute. See, whenever we go for a square root, question somebody has asked is root has got plus or minus how you do it. And in trigonometry here, we are taking root positive answer only. So the question of minus and doesn't matter. Root of 4 is plus or minus 2, I agree. But here we take only plus. It is plus or minus, not both. So we choose plus only. That's an understanding. Here, you have got cos inverse, we want cos inside. But you don't get cos, you are going to get sin. Because the formula you can guess here is sin 2 theta is 2 tan theta over 1 plus tan square theta. But if I had got cos inverse of cos 2 theta, problem would have been easier. So let us try this. Put x is equal to sin theta. You get y is equal to cos inverse of, sorry, not sin theta, but x is tan theta, because we are using this formula. 2 tan theta over 1 plus tan square theta. So y is equal to cos inverse of sin 2 theta. We want cos, we have got sin. Normally in first place students always tell them, if you want to convert sin to cos and cos to sin, give the medicine pi by 2. Let angles. Sin of pi by 2 minus theta is cos theta, or cos of pi by 2 minus theta is sin theta. To convert sin into cos, use the medicine pi by 2. So this formula, if you remember, I want to convert this sin to cos. So what do I do? What do I do? Cos inverse of, I write this as cos of pi by 2 minus 2 theta. Because cos of 90 minus 3 sin 2 theta, I will write it in this. So that I get cos of cos inverse of cos. It is pi by 2 minus 2 theta. What is theta? Theta is tan inverse 6. Pi by 2 minus 2 tan inverse 6. So dy by dx is equal to pi by 2 is a constant, it is 0. There is a minus sign, minus 2 as it is, 1 over 1 plus 6. Cos of, yeah, definitely you can. Somebody has asked me, can you take sin 2 theta as cos of pi? Yeah, we got to take. This is what I am suggesting. So we'll close the class today. I just explained how to solve inverse trigonometric functions using trigonometry results. You are all very lucky. In NCERT textbook, there are 7 or 8 problems maximum, and one of them they are going to give, and almost all of them I have solved. If in case I have not solved any one of them, you can ask me to again. Earlier, when we were prior to 2014, we were supposed to solve about 20-25 questions in one. So many problems are asked. Okay. With that, one student has sent a message. Thank you, sir. I am a student in university in USA doing advanced mathematics. I thought of encouraging you, so I say thank you, Srinivasan, a teacher. We are studying higher than maths here. Anyway, thank you, Srinivasan Kalyanan, for attending my class. And that shows your interest in mathematics. Okay, we'll wind up the class today. From tomorrow, I will be solving the question papers. Once I start the question papers, I require the list of formulas that I have given you, the list of tools and rules, whatever is given, I will be writing again. The list of formulas that I listed today. Those who have not attended the classes, I would advise you to see the previous videos and copy the problems and keep it with you. Then only you will be able to understand what I teach. Because I will not be able to repeat the problem again and again. This is my request. So just watch the video. This is 7th video that I first, excluding the first one where that was only for the sake of setting up YouTube. The remaining 6 videos I started with 31st. I'm giving the list of formulas. Today also listed them. Go through that. So we will meet tomorrow at 7 o'clock and start the question papers. I'll be first working out all 1 mark questions from 2014 to 2024. I also include the questions from the 3 model papers which have been given by the PUC board. Some student has written, sir, I am taking test today. Can you wish me? See, my wishes are always there for every student. The very fact that we are teaching is to wish you the best. And I think Srinivas Kalyan already wished that particular student. Anyway, teachers are all here to wish you all the best. But any wish will come true through hard work. There is no substitute for hard work, that you should remember. And do your work systematically and give whatever time available devote for studies. Then certainly you can make your dreams come true. Wish you all the best. We'll meet tomorrow at 7 o'clock.